Hi grade 8s, welcome back to another one of our video lessons. So today I'm going to help you with exercise 10.7 and we're going to continue with the construction of quadrilaterals on the next page. So let's start with number 5. So we'll look at 5 and 6 and then we'll continue with the theory. So number 5 at exercise 10.7 on page 103 says construct triangle PQR with PQ 10 centimeters, QR 9 centimeters, and PR 11 centimeters. Right, so this is one of the ways to construct a triangle when we are given three sides of the triangle. Okay, so I like to pick the longest side, PR 11 centimeters. I'm going to measure 11 centimeters and call that PR. So PR. Okay, then what I do is I take my compass, I set it at QR equals to 9 centimeters. I put it in R, I make an arc there. Then I set my compass to 10 centimeters, PQ, make an arc over there. The point of intersection is where is the third point of your triangle. So this is PQR. Okay, so that's how we draw a basic triangle. You can put the measurements on it. So this is 10 and this is 9. Yeah. Okay. Then they say drop a perpendicular line from P to QR and let it cross QR at A. Okay, let it cross QR at A. So P to QR. Here's our P, here's our QR. They want us to drop a perpendicular and let it cross QR at A and continue onwards. Okay, so this is when we drop a perpendicular from a point. Remember how we do that? Put your compass point at P, stretch it out further than this line and make two arcs on that line like that. Okay, then you're going to take your compass, you're going to put it into those two arcs. First there, you're going to make an arc there, put it into here, make another arc. Okay, now if you join your P and this intersection over here, that will give you a perpendicular line which is at 90 degrees. So that's what they told us to do. So I'm going to draw that in. This is 90 and they say call this point A. Okay, so it crosses QR at A. Number 2, Q to PR and let it cross PR at B. So Q to PR, Q to PR, same thing. Put your needle point in here, open up your compass further than the line so it makes two marks on this line, so there and there. Put your needle point into here, open up your compass to some distance, make an arc, put it into there, make an arc. Okay, then join this point with the point that we have there, the intersection, and call this point B and 90 degrees. Okay. And then the third line is going to come from R to QP. It's going to cross QP at C. Same thing. I'm going to stretch out my compass, make a mark there, put my compass into those 2 points, make two arcs like that. And then I'm going to join this point to R. This is 90 degrees and this is point C. All right, guys, that's pretty much what they asked us to do. Then they say, what do you notice about these three perpendicular lines? Well, they go all through the center of the circle. This is known as the orthocenter. Okay, so if we put our compass point into here, we can draw a circle around this triangle. Okay, which we'll do in the next exercise. Right, D, determine the values of PA times QR. So you guys are going to work these out and tell me what you think. And E, what are PA, QB, and RC called? Okay, so they are called altitudes, which means they measure height. Okay, remember when we do area of triangle, it's half base times perpendicular height. Well, this is the perpendicular height of the triangle from each side. Okay, so that's why they're called altitudes. Right, number 6, A. Construct triangle DEF with DF 9 centimeters, DE 11 centimeters, and D angle D 60 centimeters. Okay, guys, this is the other way of making a triangle. You have two included sides. You have a 60-degree angle that we know how to construct, and they are pretty much asking for the same thing. B says construct the perpendicular bisectors of DE, DF, and EF and label their point of intersection K. All right, construct the perpendicular bisectors of DE. All right, remember, perpendicular bisectors are not what we've done here. A perpendicular bisector takes, let's say we have a line. If I want to bisect this line, I'm cutting it in half at 90 degrees. Okay, so what they're asking us to do there is to we draw a triangle and then bisect all the lines at 90 degrees. Okay, and we did that earlier in the examples. Right, construct circle with radius KE. So put your compass point at K, stretch it out to E, make a circle. All right, join the midpoints of DE, DF, and EF to F, E, and D respectively. What do you notice about the lines joining the midpoint? Okay, once you've guys done this, you can comment on what you notice. All right, so give that a try. I'm sure you guys can handle it. Let's now continue with constructing quadrilaterals. Okay, remember, quadrilateral is defined as a four-sided figure that has two opposite sides parallel to each other, okay, which makes them also equal to each other. Okay, so two opposite sides are parallel and equal. All right, so let's learn how we're going to construct this parallelogram or quadrilateral. So a parallelogram can be defined as a quadrilateral with two pairs of opposite sides parallel. You can accurately construct a parallelogram if you know the length of two adjacent sides and the size of one of the angles. Okay, so what they're saying is that since in a parallelogram, so I'll draw an example here. So something like this is a parallelogram, meaning that that side is parallel to that side, and this side is parallel to that side. Also, this side equals that side, this side equals that side. Okay. So what they're trying to tell us is that if we know two adjacent sides, either of the sides, because the opposite sides are the same. So if we know two, and any one of these angles, we can draw this parallelogram no problem. Okay, does it matter if it's an included or non-included angle? Well, no, because it will always be an included angle and we can always work out the other angle. Why? Because remember, parallel lines, we have co-interior angles here and we have co-interior angles there, which means that these two angles add up to 180 and these two angles add up to 180. So if we know one, we can always get the other one and fit it to where we have the two sides. So it really doesn't matter what angle or what two sides, because there's only two sides and two angles. All right, so the example says parallelogram ABCD has AB 7 centimeters, angle B 60, and BC is 12 centimeters. 1. Draw a rough sketch of ABCD. All right, so let's quickly draw a rough sketch. So they have parallelogram ABCD. Angle B is 60. So we have something like this. This is 60 degrees. This is angle B. So this is AB, C, D. Okay, and what are the measurements? AB is 7, BC is 12. AB is 7, BC is 12. Okay, so this is what we need to construct, but we obviously need to construct it perfectly. We know that these lines are parallel, or we need to make them parallel, and so are those. And these are the same, and those are the same. Okay. Well, this looks like a 60-degree angle in equilateral triangle. So we can definitely construct this angle. We can also measure out these 12 centimeters here. once we get the angle, we can measure the 7 centimeters here. So we can get half of this figure, no problem. Okay, so let's quickly do that, and I'll show you the tricky part. So what I do is I draw a construction line. On it, I measure, what do we measure? BC, 12 centimeters. So this is B, this is C, and I measure exactly 12 centimeters. Right. Then what I do is I construct a 60-degree angle over here. How do I do that? I set my compass here, open it up to some distance, make a mark here, make a mark there. Take my compass point, put it into here, keeping the same distance, make a mark there. This gives you the 60-degree angle that we are looking for. Okay. Now they tell us this other side is 7 centimeters. So all I do is I set my compass at 7 centimeters, make a mark, and that is my point A. Okay. Right, so that was the easy part so far. There's nothing new. We know how to do this. Now, what we're going to do now is we're going to join A to C with a construction line. Okay. Now, remember what this figure looked like. It has to have another line on the top like that and another line going down like that. So I drew it in dotted lines just so that we can imagine it. Now remember, this line is parallel to that line. Parallel lines tell us about alternate angles. So what we need to do is we need to measure somehow this angle using a compass and recreate it over here and do the same with that angle and that angle. Okay. All right, so this is what we're going to do. Okay, you can also follow in the textbook if you guys are a little bit lost. So so if you look in your textbook, there's a green marking and the red marking. Okay, so the green marking measures this angle and the red marking measures this angle here. Okay, so it's a little bit confusing, so I want to walk you through it. Okay, so what we're going to do is okay, guys, I also had to pause there and double check how this works, but it's not too confusing. Okay, so what we do is we put our compass point over here, we open it to some distance, and we make an arc like that. Okay, can make it even bigger. Now, keeping the same distance, you're going to put that compass point here and make the same arc across that side like that. Okay. The key is that it's got to be the same distance arc. So we're going to put it into C, make an arc, keeping same distance, put it into A, make another arc like that. Okay, now remember with the alternate angles, we need to measure the angles somehow. So what I'm going to do is I'm going to put my compass point over here at this point, open it up to here and make a mark like that. Okay, so that distance essentially measures our angle or the distance between these two arms, okay, or it completes the triangle. So we need to do the same thing over here because remember this angle is the same as that angle over there. So what did we do? We took our needle point here, we put it here, we measured that mark. Now we're taking that same distance, we're going to put our needle compass point here, we're going to open it up, or we're going to keep it at the same whatever distance was here, and we'll make an arc there. And you'll see that this intersection here and this point, if you line them up, it will give us the other side. But remember, we want to do the two sides, and where they cross, that's going to be the intersection. Okay, I suppose we could also measure it. We could do that as well. So you could just measure this, what do they say? 7 centimeters. Okay, so either way, we measure 7 centimeters. There it is. Now with this line, how do we make sure it's the same level as that? Well, it's the same alternate angles. So this angle here needs to be the same as that angle there because of alternate angles. Okay, we already drew this arc. So what I'm going to do is I'm going to put my compass point here and measure there and make a mark like that. Okay, no, I'm lying. Not on this side. We're doing it on this side. Okay, because these two angles are the same, we have this, remember, we only have this triangle. So we have that angle and that angle. So with this angle, since it's the same distance arc, I'm going to put my needle point here, open my compass to this thing and make a mark there. Keeping it the same distance, I'm going to put my needle point in here, open my compass, make a mark there. Now, the intersection between those two arcs and this point will exactly give me a parallel line, and it will make a parallelogram A, B, C, D. Okay, guys, so that's how we construct a parallelogram. Okay. Number 3, measure and record the sizes of all the angles and sides on the construction. Okay, you guys can do that once you've measured it. Number 4, show that BAD plus ABC plus BCD plus ACD equals to 360 degrees. Okay, so once you've drawn this accurately, you can measure the angles, put them all in, add the angles that they listed, and see what it gives you, and see if you get 360 degrees. Number 5, what do you notice about the relationship between A, both pairs of opposite sides, both pairs of opposite angles? Okay, what we notice is that both pairs of opposite sides are equal, and both pairs of opposite angles are also equal. Yeah, suppose I gave away the 7 centimeters because we didn't really know that they were the same yet, but we didn't have to measure. We could have just drawn a line from here to there going up, and then a line from here to here going across, and it would have given us that intersection point to give us point D. Okay. Alright guys, so that is the worked example on constructing quadrilaterals. I want you guys to do exercise 10.8 for homework, and that would be the end of that section. So for homework and the weekend, I want you to do exercise 10.8. Okay, and then we'll continue in the next lesson. Cool guys, thank you. Ciao.